Hello everyone, welcome back to Structure Expert. Today we continue to analyze and design in CSI Etabs version 20.2.0. In the previous tutorial 3 you can check in my YouTube channel. Now we discuss about analysis and design in Etabs. After we complete and run analysis, now we continue to design. Click on design, concrete design, view, revise preferences. You can change the design code. The country we use the default country CCEN default. You can change to the Finland, Germany, United Kingdom, and combination we use combination equation 6.10. In the method for design, you can use a curvature method or use a nominal stiffness method. In Etabs, you cannot design based on general method. In Creative Advanced Design 2023, you can use a general method to design for the column. The general method is the more accurate method for the zero code user, both for the steel and for the concrete structure. Number of interaction, gamma, okay, click OK, and click on member. You can check the view, revise overview, frame type, and column design section, and press length ratio. You can keep it 1, and press length ratio 1, and press length ratio is 2. The column height is 8, and for the unpressed column, unpressed or spare column, cantilever, the effective length is 2 times of the height of column. Now let me change to 2 and 2. Click OK. Click on design and concrete, group all, design, concrete, select design combination. You can list all combination. We has only one load combination. You have to import for load combination 1. In case if you do not import, the tab will be create another new load combination for design. This one for analysis. Come back, load combination. We has only one load combination. You can modify and check load combination nonlinear, and scale factor is 1. Now in the case if we do not import load combination 1, this software will be automatically create another new load combination. Now let's try. Okay, design, concrete, start design and check. This is the section or the column if fail, cannot resist the apply load. Now come back to define and load combination. You see here now there are 3 load combination. The first one is load combination 1, modify, nonlinear load case 1, the scale factor, and the 2 is automatic load combination created by a tab after you design the member. Click modify, did load, include with the combination 1. So it now the ball with the scale factor is 1.35 for the load. It's not correct. And this one also did load like load, and with the load combination 1.35, so it's not correct because in the case we do not want to change the 2 load. We want to keep only 1 load. Okay, this is the ultimate load, but the scale factor we use 1 because we apply all the joint load is the ultimate ultimate load we apply after we multiply with the factor, the safety factor. You can come back and check. In the case we assume apply only one load case, we do not focus about the load inline load, and this load is scale factor load, is ultimate load. So we do not want to use the two load combination. Now let's check about the design. You can design concrete frame design. Click on display design info. Now let us put the design longitudinal rebar or column PMM interaction ratios. Click apply. The interaction ratio is over 1. This section is not pass. It's fair. Click on the member, right click. The story 1 column section is 50 multiplied 50 centimeter. The column name is C1. Now let's check at the station, this station 00, and you can check here there are 3 load combination. The combination 1, the combination S2 and S1. Okay, now the combination F1 F2. Now let's check again in design concrete, select load combination. Okay, now this load combination decon S1 and decon S2 due for design of the column, not load combination 1. And come back, double click and click on detail. You can check for envelope. Now let's check Etabs concrete frame design. The element section correct, length correct, and type section correct, and C concrete modular elasticity, design strength, concrete strength, or rebar, design shear strength or rebar is correct. The safety factor for the concrete for the flex rod is 0.85 alpha cc. For the UK national net is correct. If you use the default CEN, the value alpha cc is equal to 1. For the flex rod member is equal to 0.85. For the shear is equal to 1. Okay, correct. So let's check column fair. Now let's check about the design. Check about the imperfection. Okay, analysis. Now let's check the analysis moment is 616 imperfection. The total moment about measure assist is 688.35, and for the M2 is only 44. And the measure moment and eye moment is 2021.71. This moment is not correct for the further moment. Actually it is the second order moment. We include the second order analysis, so the value is should be the same with the Etabs result is 748.78 kilonewton meter. Okay, earn moment, this one at the back, earn I and earn G at the top of column. Section imperfection include the imperfection of the member and the moment. Now this result is not correct with our concept. Now you can screenshot snipping shoot. Now let's check about this moment in the folder. Come back, close. You can output it to the Word file and call it object cantilever lever column result. Okay, close and come back to review about the result combination 1. Check. Sorry, we want to display about the moment combination 1. Yes, it only 748.78. Now let's check for other combination. Yeah, this one. It 2021.22 kN/m for earn I is the I, and at the top is G, node I, node G, and at the top is 616. At the top, yeah, 616. Let's close, and now we have to correct this situation. We got some error. Click on define, click on load combination, delete the two load combination, delete combo. We want to keep only one load combination. Click OK. Click on design, concrete frame design, click on select design combinations, import load combination 1, click OK. Click on design, click on start design and check. Now let's check again about load combination. Yes, no other load combination is generated. And design, display design info, click OK. The design result is over 1. So this member is not passed erasure. Now let's check about the detail. Maximize, zoom 150 times. Now let's check the column length is correct and concrete correct. Year strength of rebar is correct. Now let's check. Okay, let's check this report. First order moment governing first order moment governing permutation, and I at the best. The result is 748.75. Yes, it's correct. Now let's save it to other version. Column version 1. Okay. Now close it, come back and verify with the result. Okay, 748.77. Open the cantilever column result 1. Yes, the first order moment measure. Actually, we run in the second order moment, not a first order moment. We include a P data in Etabs. But in the design report output in the first order moment, measure bending, measure bending about strong axis is 748.77, correct if we compare with the Etabs result. And the earn at the top is 228.28. Now let's click and right click. Yes, at the top is correct. And second moment imperfection. This is the imperfection moment generated by Etabs is 26.7. Now let's check with my result. When I apply the imperfection moment is around 24 to 28. Okay, if you use notional load around 0.3%, the moment applied by notional load is 24. If you increase to 0.35 or 0.4, the moment will be increased. And after we use the specific formula in Europe code, the global infection is 28.28. Now let's check with Etabs. Sorry, it's 26. Okay, it's 26. Imperfection it in rank. Okay, in rank it depend on national load. Okay, now in rank the moment to 2. Now let's check about the concrete capacity. Alpha cc multiply with the cross section or column multiply with SCD. You can check it. It's 12,750. Now let's check its share. Alpha cc is equal to 0.85. 0.85 multiply with the A is 500, multiply with 500 and multiply with SCD. SCD is 90, 1.5. Yes, the result is the same. And compression ratio, you use the NED over the alpha cc multiply with A or multiply with SCD is 0.079. Compression limit is 0.55. Now let's check about detail for the measure axis. Okay, this one is the measure bending moment. Now let's check about the measure bending. Analyzing moment. Analyzing moment. Sven by yes, this one. The measure bending moment 775.47 is your calculator. 748.7854 plus 26.7. Yeah, the result is 725.4753. The O2 is the first the O2 is equal to the moment at the end of showing E plus with the imperfection. So the result is 775.48. Now let's check about the result. Okay, this one, the larger earth moment. In the case we has two moment, the smaller is at the top is 243.299. This one is the smaller value of the moment, and at the end, at the base, at the column is the maximum. The maximum moment is 775.84 kilonewton now, and the equivalent moment and slender now is correct. All column is made in the slender because it's a long column with space, and it is equal to AI or OED. Okay, and K, the second order moment. This one is the second order moment. Second order moment is 287.36, and now the moment is 854.65. Now this is the final moment in Etabs 854.65. Yes, that's correct. Now let's compare with the design menu. Come back to slide. When we verify it manually by using amplification or by using magnification factor in ACI code, the final result is 896. You see here in the Etabs, you cannot check it directly in analysis, but it add more moment or magnification you in design parameter. You have to check in design result. I explained you when you output direct in analysis result, this result is only show 848.78, but for the total moment in the tab you must to check it in the output design result to get the final maximum moment. Okay, apply, select member, and check for the station 8. Sorry, this one we have to check at the station 0. Is station 0 at the base? Okay, at the base of column. Station 8 is at the top of column. See here, this one at the back of column. Yes, at the back of column is 869.7. If we compare this result, okay, this one is larger. This one is correct. We compare at the back of the column, at the location, at the station 0, 0 at the back. Now let's check the final moment in the tab is 869.70. Okay, now let's add new in a tab, second order moment, and this one is not include amplification factor manually. It automatically in the design result. So I design result in a tab. The final moment, the total moment is now let's check it. E 869.1 now. I round it up to 870. 870. Let's compare. When you use the amplification factor or magnification factor in a tab manually, you can check in my previous tutorial monitor about how to calculate this value for the second moment and for the total moment at the best by using amplification factor. And now we just want to check in case we run analysis with second order and run design directly, what is different the final total moment compared with using manual amplification factor. The manual amplification factor output from Etabs and we input in Excel sheet or calculate it manually and multiply with the second order moment to magnify the value to 896 kilonewton, and the total moment in the design result of Etabs is 807 kilonewton. Now you can check it what is different. Yes. Now how many is different? How many percent is equal to 896 minus 870 over 896. And you can select for the percentage. And what is different when you use the amplification factor or magnification factor manually and multiply with the second order moment, and the final moment at the design report in the tab, what is different is around 3%. Okay, now let's check if deviation is acceptable or not. You can check it, and we will discuss more about design result. Yes, design result is now fair, not pass, because it overstressed. We will discuss more about the friction limit. Okay, come back to result. Come back to slide. Okay, now we talk on this topic. When the design the result of the delta 2 over delta 1 is less than 1.052, you can design it as non-sway, but if the result is greater than 1.0526, we must to include the second order effect. We design it as sway frame or unpray frame. Now let's check in the case the okay, copy paste, copy paste, copy paste. Now let's check when the delta 2 over delta 1 is greater than 1.05, or you can round it to 1.5. The column is sway column or unpray column, and you should limit the upper limit. This one is lower limit for sway column, and the upper limit you should limit it in the recommendation in the code. If 1.4 you should limit the value of data 2 over data 1. This if the value is greater than 1.4 you must to modify your section, to add more strictness on your section, to add more strictness on your pricing system. Okay.